Hello, my name is Masu. I'm a chemical engineering master student from the University of Cape Town. My topic is verification of mercury-free technologies in artisanal and small-scale gold mining. So artisanal and small-scale gold mining refer to individual miners, communities, or small businesses in the gold mining sector with a limited capital investment and production. So they are characterized by use of semi-mechanized tools and techniques. So this is a largely poverty-driven exercise for most of the miners, especially those who do the manual labor, because in their structures, there is no salary, everyone is equal, you get a say, but in terms of the dividends, that's where they get less of it. So for them, it's about getting money for the day and getting bread for the day, surviving for the day. Then tomorrow, back to it again. So they start off with the mining process. So the process starts with exploration. The exploration is pretty basic at best. The miners search for quartz rock just below the topsoil, which is predominantly clay. So when the quartz seam is located, mining commences. The rock is too hard to use picks and axes, so they use anfo explosives to blast the rock. Chuck hammers are used for further loosen the blasted material, which is then loaded on metallic buckets which are enforced to trap outside. So these are the metallic buckets, and this is the check hammer, and these are the drill bits which are used to bore the holes on the quartz for blasting. So the material is loaded, then hoisted up from the shaft onto the surface. So onto crushing and sluicing. So the raw ore is further reduced in size first using hammers, and then fed into a hammer mill using shovels, with water also added into the process, as you can see in the first frame. So in other instances, the ore is transported to processing centers where they use stamp mills, which is on the third frame. So stamp mills have a higher capacity than hammer mills. So a stamp mill will be processing in the north of 10 tons per hour, while a hammer mill goes to 0.5 to 1 ton per hour. So the hammer mill is coupled to a sluice which is lined with mercury or a cloth. So if it's lined with mercury, this is all amalgamation. You'll get some of the mercury losses with the tailings. So your gold nuggets will be trapped on the mercury which is lined at the bottom, and they recover the mercury there. So if they use a cloth, they have a material which is gold, gets trapped on the cloth while the tailings flow into the pond. So the pond is a dewatering pond. So when the ore is dry, maybe after 2 to 3 days, it's shoveled out, then it's ferried to the leaching tanks. So the cloth is washed and they concentrate the ore by using panning and amalgamation. So this is a further processing step. So the panning and the amalgamation are done simultaneously. So in this process also you will lose traces of mercury with the tailings. Then onto the roasting. So the amalgam which is formed is roasted on a burning log. So this takes about 2 minutes, and the sponge gold which is recovered contains 6 to 10% of mercury by mass. So during this roasting process, the mercury is breathed in, as you can see in the frames, when it's blowing, which causes danger, which is a danger to the person doing it, because this leads to problems with the nervous system and can also lead to death ultimately. So in the first frame, that's your sponge gold which was produced from that process. So your tailings will go for leaching. So this takes 3 to 5 days. So the problem is when your tailings contain mercury, on contact with cyanide, mercury cyanide is formed, which is more dangerous than mercury or cyanide. So it's very poisonous to the environment and to people also. So after the leaching operation, the tanks are drained, the ore is shoveled out, put at the side, new ore is put in. So the ore is not rinsed off of the cyanide, which is in there. So all the cyanide, which is still on the ore, when it becomes rainy season, is washed off into the ground and seeps into lakes, rivers, and into the environment, which is a danger to the environment itself and to people and the animals. So the problem statement reads, regardless of the non-negative impacts from mercury usage and this combination with cyanide, it remains a technology of choice in this sector, even though alternative technologies have been made available by researchers. So this raises a question as to why these technologies are preferred. So I will do a study on 2 promising technologies, which are the Igoli process and the cyanide-glycine lixiviant, and verify their validity first and what the barriers to uptake of them are, and then package them for uptake by these miners. So the objective is to verify these technologies for uptake by artisanal and small-scale gold miners. So the idea and the objectives are to carry out a comparative study on the gold extraction when using the miners process versus the Igoli process and cyanide. Which one is more efficient in extracting gold? Which one is the better extractant? Which one is the more efficient process? Also analyzing the process parameters and also carry out a basic costing on how much is needed for capital and also operational costs, because we know the miners have a limited capital. So anything which would be too expensive would be out of reach for them. So to this, the research approach would be fieldwork has been conducted already to understand the process, which is the mercury and the cyanide, and also the socioeconomic dynamics, because this matter when we are packaging something for uptake. So what is realistic for them and what works best for their process, what easily goes, which technology can be easily uptaken considering the process which they have, the manpower and the knowledge which they have. Then we have all mineralogical characterization. So the mineralogical characterization will help in designing the best process for extracting the gold from the minerals it is locked inside. Then extraction efficiency of mercury versus that of the Igoli process in the cyanide-glycine, taking into note the best conditions of extraction for each. This is your pH, reagent concentration, your mixing ratios. What are the expected capital and operational costs? And is it easy to carry out? If the process has too many control parameters and there's need for a scientist or an engineer to be able to actually run it, then the uptake would be low considering the level of education of the miners. So the mining processes leaves shafts which have collapsed, some which are still in place, and there's dumps everywhere from the rubble and the waste from the pit which they don't use. So they don't close off anything. There's no cycling back to cleanups, because cleanups to them waste time. So any time which is wasted on cleanups is time spent not making money, and that means no food on the table. So the processing also releases mercury and mercury cyanide, which damage the environment and which lead to disability and ultimately death in humans and animals. So by using a better technology, which can increase extraction efficiency and be safer to the environment, we will line the miners' pockets with more money. So when they are financially stable and sustainable, it will be easier for them to think of the environment and the surrounding communities as well, and their well-being and the well-being of everyone else. So this will lead to achieving SDG number 8, 13, 14, and 15, which are decent work and economic growth, climate change, life below water, and life on land. So I would like to thank the University of Cape Town, Chemical Engineering Department, specifically the Minerals to Metals Initiative and the Hydrometallurgy team for all the help, assistance, and the funding.